Hi folks, this is a predictions video for the Leaving Cert Higher Level Maths Paper 1 for 2025. So what comes up every year. Now this is a spreadsheet here. It's got a very rough kind of description of what comes up in each question. Now some are harder to describe than others, but I've made a good attempt at describing the part A, B, C and so on for each of the questions for each year. So I've got the first four, I've got a few more years actually, but if you look into this box here, that's what came up in question 1 in 2024, that's question 2 in 2024 and so on. So there's obviously some patterns and I'm going to go through those now. What I'm going to go through is an overview of topics which have come up in exam papers for the last 4 years, a list of recurring topics to focus revision on, links and QR codes to full videos, video solutions to questions, and I've got the 2024 exam work solutions and links and QR codes. I'm focusing on all of the questions really that came up from the recurring topics in 2024. So any questions and work solutions you're going to see is from the 2024 exam, and it's just to give you an idea of the most recent type of question that came up on each topic. The topics that I'm going to focus on this year are these: the Moivre's theorem. Now differentiation, all of those things came up in 2024. Equation of tangent, point of inflection, first principles, and basic, just differentiating a basic function. Now I might have missed, I think the quotient rule actually came up as well. I might have missed one or two others, but I've just included questions on those for you to see. Trees, sequences, then factor theorem comes up every year. Average value, that's the integration with the average value. And then filling in a table and drawing a graph, that's when you're given a function and you're just putting in values from the table in and getting out what f of x is or whatever. And then you're drawing a graph. That's probably one of the easiest questions, definitely in section B anyway. And then integration is that integrating a basic function come up in 2024 there, and integrating the area under the curve as well came up in 2024. And I'm going to go through all of those questions now. Now obviously I could have picked some more topics as well, or I could have picked some less topics. There are more recurrent topics as well as these ones. It's just that I think these are some of the ones that are probably the easiest to get marks on, and these are the topics that I'd really focus on first in your revision. So when you're going to start really getting down to your studying for the Leaving Cert, these are the ones I'd be hitting first. Just make sure you know all of these and know the few different ways that they can come up, because you're more than likely going to see them in 2025. And from there then you can go and you can explore, you can go and look at other questions and really go through your exam papers properly, but I'd get these down first. So the first one anyway, the Moivre's theorem, that it came up in question 2 there in 2024. I'm going to show you that question in a second. Then in 2023 it came up in question 4b. Then in 2022 it came up in question 3b. It's the biggest part of complex numbers really. And then in 2021 it came up in 1b, and it came up in 1c as well, where you have to find the roots. Finding the roots is a little bit harder, and there's nothing to stop it coming up in 2 different questions or 2 different parts of questions. The question that came up last year, and there's a QR code there, that has the full solution, and it's the same for all the questions if you want to go through and look through it properly. But you're just putting a complex number really. It's hard to make out what it is there. It's 1 minus root 3i all to the power of 9, and you have to go and put that into polar form first of all, and then apply the Moivre's theorem to it. And that was it. That was the part B of the question. The next one, it's differentiation. It's the equation of a tangent to a curve. I'm just going to show you differentiation overall here first and where it comes up. Last year it came up in question 4 there, and it's generally always going to come up in section B as well, in questions 7, 8, 9 or 10. Anywhere we see differentiate in there, question 10 it comes up again. The rate of change, that's quite a hard question there. In question 9 it came up. Max and min in question 8, and differentiation of E in question 7. Comes up in an awful lot of different places. In 2023 then, it'll always come up in kind of question 4, 5 or 6, generally around there. There it comes up in question 5 for 2023, and then towards the end of the paper, so 7, 8, 9 and 10, it's going to be coming up again. Comes up in question 7 there, just differentiating a basic function, and then max and min, finding max and min. Comes up there, change in base actually comes up again. I haven't got an example of change in base where it came up here last year, but it is quite a hard question, but it does come up quite often. There in 2022 then, comes up in question 10 again, differentiating with logs with ln. Point of inflection comes up there. Second derivative comes up there, question 7. Then it comes up in question 5 as well. It'll always come up in section A and in section B. And then in question 5 there again in 2021. A lot about differentiating a basic function. Finding and using the equation of a tangent. That's the same then as this year. Or sorry, as 2024. Then question 10 again. It's generally coming up in question 10. And a bit in question 9 there as well. So in my opinion, I think differentiation is probably the biggest, definitely in paper 1 anyway, but probably overall it's probably one of the biggest topics. I think you really need to know it inside out, know everything really from it, because it's so many marks guaranteed if you can just apply it. And it's a lot of early parts of it are quite simple, where you're just reducing down the power and multiplying and so on. Right, so this was one question that came up last year, was equation of a tangent. So differentiation is the slope of a tangent to a curve. Here they're asking for the equation of the tangent at that point. So you're differentiating it, you're subbing in a 2 because it's at where its x is equal to 2. And then we're subbing it back in, we're subbing that 2 back into the original function. Sorry, we're not, we're just putting in the 2, and then you're using the equation of a line formula. And because you know what the equation of the tangent is, it's the -7 there. So point of inflection, that's where we're differentiating twice and then let it be equal to 0. Here we get 12x minus 18 is equal to 0. X has to be 3/2. The nice part of this question was, it says find the x coordinate of the point of inflection. That was very unusual, I suppose. Usually you'll have to just find the whole point. So if you had to do that, which you might next year, you'll put that 3/2 back into the original function, not into one of these up here, not into that 6x squared. You put it back into what f of x was, and then you get the y coordinate, and that's the point of inflection. That's how we do point of inflection. First principles, it comes up. It didn't come up every year, I think, for the last 4 years, but definitely 2 or 3 years. And it's not too bad a process. It gets really complicated at the start, where you do f of x plus h minus f of x. But after that, it actually simplifies down nicely, usually in the end, unless you get an awkward one. This was quite a nice one here. It's just going to be 2x minus 7. Another thing about it is you always know that you get it right. If you go back up to the top there, and you differentiate that equation, the f of x equals x squared minus 7x minus 10, it has to obviously be 2x minus 7 when you differentiate it. So I know I got the right answer there, so you know before you leave the exam that you got the marks. This was part of question 10 then. It was where you're just differentiating that function there, so it looks a bit awkward at 0.667x and so on, but it's just differentiating as normal, and that's one part of it. And I think then after that you had to sub in a number in and so on, so definitely some easy marks there. Right, I'll move on then, we'll go on to sequences. Now, arithmetic sequences and geometric sequence comes up there, question 5 in 2024, just last year. And then in 2023, I think just there in question 8 comes up, so generating geometric sequence. And then in question 4 there in 2022, subbing into sequence, using arithmetic sequence to form equation. That's similar enough to what came up there in 2024 actually, where we're using an arithmetic sequence just to form an equation. There it comes up in question 9 again in 2022, geometric sequence. Then in 2021, question 7. There's a good bit to do with sequences there. And arithmetic sequence and geometric sequence, if we know everything about those, know the general equation, know how to sub it in, know what you're subbing in where. So for example in arithmetic, know what the A and the D are obviously, and then in geometric it's the A and R. This is the question that came up there last year. It tells us the first 3 terms in the arithmetic sequence. What we have to know there is that T2 minus T1 is the same thing as T3 minus T2. They always give us what D is, what the difference is between them. And then it's easy enough to form an equation then, and then we get what P is. So the key is that it's an arithmetic sequence. We know that it has the same difference between each term. And this was part B of the same question, and this involved a geometric sequence. That general term is a r to the power of n minus 1. We're just using that really with the first one, with g7 is equal to 6, and then the second one, g11 is equal to 3 over 8. But then when you get what a is, you can put it into the other one, and you can eventually get what r is at the bottom there. That's sequences. The next one is factor theorem. Now factor theorem only came up as a little part A there last year, but it was quite an easy question if you knew what you were doing. Because x minus 4 is a factor, x equals 4 is a solution or a root, therefore we can put 4 in and it should be equal to 0, and you can easily get what b is there. Don't know how many marks it was, but it was easy enough. So it was unusual, it didn't come up in the early part of the paper. It actually came up in question 6 there as part A of question 6 last year. But usually it does come up towards the start there. It came up in question 1 in 2023. Then in 2022 it came up in question 1 as well in part C. And then in 2021 it came up in part 2B. Generally it does come up as a bigger part of a question really. It comes up in the part B or part C. Right, this one is average value. This is very consistent. It's integration really, but we have to remember we do the 1 over b minus a, and the way you see it in the papers, it'll always say average in the question. Here, use integration to find the average amount of money in the account over the first 5 years. Give your answer correct to the nearest euro. We have to watch out really for that word average, and that's a big key as to when to use this question or to use this process. There you see, that was it as part D in question 7 there. It came up in question 7 the year before as well, in 2023. Then in question 8 in 2022, and then in question 8 again in 2021. Therefore it's come up every year, and it's come up the years before as well. You see it there. Question 9 the year before that as well. That's average value, and it's just, obviously we need to be able to integrate properly there. It was integrating E. Right, filling in a table and drawn on a graph. This is an example of something that is very consistent as well. It's probably the easiest. I said at the start, it's the easiest thing in section B to do, really. It's a great way to start a question because you can get through part A or maybe part B sometimes with full marks. Here we're just putting in all those values: 0, 60, 120, 180, 240, 300 and 360. Some of them are done for you, but you're just putting those in instead of x in the function, and you just write down what you get for each one. The second part then, it's just plotting it on the graph. So our x coordinate is the 0, our y coordinate is the 6, so 0, 6. Then we go to 60, 43, and we just keep plotting them, and that's it really. So this will always be in the section B's. There, question 8 last year. Question 9 the year before. Question 8 the year before that in 2022, and then in 2021, question 8 as well. We're filling in a table, and it's always like that. It's filling it in, just putting in what the x value is into the function. Right, we're nearly done. Integration. This was a nice integration you need to know as well. There's not going to be as much integration as differentiation usually on the paper. Sometimes it might be close enough actually. But here, this was a very simple question. It's just integrate cos 6x dx, and then we just have to go to our log tables really. The integral of cos is sin, and we have to remember that it's the opposite really of chain rule, because we have to divide by the differential of what is inside the brackets there. The differential of 6x is 6, so we're dividing by that because we're doing the opposite of differentiation. Then integration under the curve. I'll go through where integration came up in a minute, but it looks a tricky question, but it might be hard enough to make out there. It gives us a hint here at the bottom. It says find the area of the logo in the first quadrant and then double it. We're integrating between 1 and 0 because the shape only goes to 1. It's marked there on the x-axis for us, between 1 and 0, and then we just do what the s of x is. That's the 2x minus x squared, and we take away what c of x is, which is just x squared, because everything in between those two lines will be what the area is there in that first quadrant, and then we get that. I think I have to multiply that by 2 actually at the end then again. But that's it, and it's just integration, and from there it's just being able to set it up. It's just being able to interpret it there off the graph. So if we look here, when integration came up there in question 10 last year, integration to find volume there, question 10 the year before. I can't remember that question. It'll generally come up a little bit in section A and in section B. Differentiate there. Integration under the curve came up the year before as well. Integration involving E came up the year before as well. I know integration is a broad enough topic as well, but if you're just able to know those few bits, be able to integrate different things, just basic function there, area under the curve again in question 2 in 2022. Integrating a basic function, then probably come up down here again. It comes up in that average value as well, which I've gone through already. Integration of a function there, part C of question 6 in 2021. I don't see much of it there in 2021 actually. Integration is a broad enough topic, but if you're just able to integrate a basic function, able to integrate with E, able to integrate trig, and then the area under the curve, and there's not really much else that's going to come from integration, and it's guaranteed to be on the paper, hopefully in a few different places if you're good at it. Right, that's all I'm going to go through for paper 1. Again, those are the topics. Now I could obviously, if you might have seen there yourself, if you pause the video, you might be able to look through and find other themes of things that constantly come up year in, year out, or are fairly prominent. But I think these, generally, I think you should know differentiation kind of inside out. You should know, like I said there, about integration. Things like the factor theorem, that average value is always a constant question. Being able to fill in that table, being able to fit into a function, things like that. The Moivre's theorem is the biggest part of complex numbers. Sequences has to really be on it. It's a big enough chapter, and I don't think it can really come up in paper 2. And that's it. So if you want to look back through it, pause it, click on those QR codes or the links, and look through the questions properly. Then go back through the other years, look back at different ways that it came up, and that's how I'd start my revision if I was you. Get all of these nailed down, and then go and look through the papers and branch out a little bit more. So that's it. That's all for the video.